Welcome back to Orlando Math Learning Academy. My name is Nguyen, and for those who just know me the first time, I have my mechanical engineering degree and I have my master degree in mathematical science. And I've been a math instructor and professional tutor for a pretty long time. That's a quick introduction for those who doesn't know me. Okay. Uh, so far, this is the fourth video, and in the last video, we learned how to examine if the table represents a function or not by look at the x, right? The x means the input, and look at the y, which is the output. In this video, we learn how to if the graph represent the function or not, and by doing that we learn a test is called a vertical line test. Okay, so let's go through that today. I believe today is the April 5th 2019. So it's a continuation of the video what we have left over last time. So vertical line test. Vertical line test is the test to examine if the graph represents a function. Okay, and in vertical line test say that given a function f(x), okay, no order pair can have the same x coordinate in the graph of function. Okay, or literally it means that if you draw a vertical line, literally a vertical line intersect the graph more than one point, that graph does not represent a function. Okay, example, if I give you the graph something like this, okay, it's the y-axis and the graph kind of look like this, and you see that when I draw the vertical line through the graph, it cut the graph at more than one point. Instead of cut at this point, it cut at another point. So it look like this where we cut at 3 points. So if it cut more than one point, the graph here is not a function. Okay. However, if it cut only one point at everywhere on its domain, for example like this, This domain is from here to here, right? X1 here, X2 here. Domain here is between X1 and X2, right? I put a bracket because I use the dot here. So no matter what I draw the line anywhere over the graph, it cut the graph only one point. See that? And as long as you draw the vertical line at anywhere over the graph and it cut at one point, then this graph represents a function. So this represents a function. Okay. I can have something, another example, something like this. Okay. And no matter what, I draw the vertical lines anywhere over the it cut 2 points. See, if I draw vertical line here, it cut 2 points. If I draw here, it cut 2 points. So this is still not a function. Not a function. Okay. And if you realize this, if you can realize this, sometimes the function is increasing, or sometimes it's increasing, sometimes it's decreasing, and sometimes it's not increasing or decreasing. Sometimes it's just a vertical, a horizontal line. Okay, then how do we know that? How we investigate in what part of the interval or what part of the domain on which the function is increasing, and what part of the domain on which the function is decreasing. So in order to investigate that, we have to learn another concept. It's called increasing or decreasing concept. Okay, so increasing and decreasing or constant function. This concept is sometimes, believe me, if you really look into that, it's pretty confusing. And because at this level, you just the graph you learn is very basic. In higher level, the graph is very complicated, and sometimes you don't know if it increasing or decreasing, and it's very hard to write the interval on which the function increasing or decreasing, because so you at that level you must learn even deeper concept of increasing or decreasing. Is called a strictly increasing. Okay, but I don't want to mention that too much over here. Okay, so before investigate increasing or decreasing, we need to know the definition. What does it mean by increasing function, and what does it mean by decreasing function, and what does it mean by a constant function? A function is increasing for any x1 and x2 on the excuse me, where x1 less than 2 than fx1 less than fx2. It means that on the domain, if you pick 2 points on the domain x1 and x2, and x1 is less than x2, okay, then the domain, then the function that will be increasing on that part of the domain. The output of x1 and the output of x1 is less than the output of x2, or we can say the fx1 is less than or lower. If you look at the graph, you will see with lower the fx2. Okay, example. If I have the graph like this, I have x1 over here, and I have something like this, and I have x2 over here, and you see that the domain is between x1 and x2. The function is defined on interval x1 and x2. I don't want to talk about the it's included x1 or x2. Right now I just say it's defined on the interval x1 and x2. Okay, and you see that fx1, which is the output of x1, is this, right? Okay, this is fx1 here, and the output of x2, which is this, is fx2. Okay, x1 is below the x-axis, right? fx2 is above the x-axis. It means fx1 is less than fx2. So the function I have here, this function, is increasing function. It's increasing function. Okay. It's increasing function. Okay. How about the decreasing function? A function is decreasing if for any x1, x2 on the interval or on the part of the domain where x1 and x2, we have fx1 greater than fx. So if you pick any point on the domain and x1 is greater than x2, okay, x1 is greater than x2. I think I messed up a little bit over here. X1 is less than x2. Okay. Any point on the domain, if x1 is less than x, output of x1 is greater than the output of x2. Example. If you look at example, sometimes it's easier to see. You know, when I just talk about the definition is very hard. Example. Here we have something like this, and I have x1 here. I have x2. Of course, x1 is less than x2, right? And I have the graph of this. Over here, I have fx1, and over here I have fx2. Okay, fx1 is always greater than, right? fx1 is right here, fx2 here. Of course, fx1 is greater than fx2. Or you can say fx1 is above. You can say it like that. okay, or the point where fx and fx1 locate and x1 locate is above uh, uh, above fx2. Oh, you can say like that, okay. Actually, the above definition is not really perfect one, because if you look at it increasing over here, the point over here is still above this point, but it's still increasing function. You know, so you say that the fx1 is more than or greater than, because you see that if fx1 over here could be something 6 and over here like around 1, right? Fx1 is greater than fx2. Okay, then we have the decreasing function. That's what is happening if we have different x, different 2 points on the domain, and the output is the same. So a function, then we have something called a constant function. A function is constant function if for x1 is different from x2 on the interval we have fx1 equal fx2. Okay. In the textbook they use x1 less than x2, but I just go ahead and say x1 is different from x2. Okay, for example, if I had a graph like this, I have x1 here, I have x2 here, and if fx1 if fx1 is right here and fx2 is also right here, the same, then you see that the graph is look like it is vertical, it's a horizontal line, right? You see that? Or it doesn't, x1 doesn't have to be smaller than x2. X1 could be greater than x2. It's just the name that you name it. Okay. The x2 here could be x1 here, as long as it's two different value of x and it gives you the same output, then we have a constant function. Okay. Let's go through some practice so that you can understand better. Okay. I think I'm gonna do example 8. Example 8 in the textbook. In the textbook on page 53. Right here. Okay. Page. On this example, they give you the graph already. Okay, they give you the graph already, and this graph is a curve. Okay, and they want you to evaluate the function, and we know right away this is a function by apply the vertical line test. Okay, if you just go ahead and draw a vertical line here, you see that it just cut. See that it cut the graph at one point only. You see that? I draw the vertical line test and then cut the graph at one point. So we know right away the graph, this graph represents a function. Okay, so as we know the graph represents a function, then we go ahead and evaluate the function at -2. Okay, when we evaluate the function at -2, it means that we want to get the output given the input x equal -2. Okay, so we look at the input. We look at the input x. x equal -2. That's what I mean. X equals to -2, and we want to get the y value. Okay, we want to get the y value. So this is the y value. When they ask you to find f of -2, it means they ask you to find the y value when x value is -2. So we're looking at -2 right here, right? And you kind of draw the line, and the vertical line, you see that line cut, cut the graph at this point. Okay, if the line cut the graph at this point, if the line cut the graph at this point, and we look the y value correspondingly, we know that y value will be -8, right? X equal -2. We kind of draw the line until they hit the graph. Okay, you don't draw it up over here, okay? Because the graph is down here, you have to draw down. The line until they hit the graph, and the graph show you the y component of that point is -8. So your answer here, f of -2, f of -2 equal -8. Okay. Now find the input when fx equals 7. Find the input. It means they want you to find the x value given the y value 7. So we have to go and find y value equals 7. So where's 7? Y. Look at the y, right? Y. 7 is 7 right here. Okay. 7 right here. Because we want to find the x value, so we have to draw the kind of horizontal line. Okay, like that. And you see that it cut the graph at 2 points, this point and this point, right? Okay. And this point is corresponding to the x value, because we want to find the input, which is to the x value, is -5. X value here at 3. Okay, so when fx equals 7, we have two input, x equal -5 and 3. Okay, you see that two different x can get the same y. However, the same x cannot get two different y. Okay, I repeat it. Two different x can get the same y, but the same x, one x, cannot get two different y. Okay, because if one x get two y, then it doesn't satisfy the vertical line test. Okay, the graph does not satisfy the vertical line test, and therefore it's not a function. See, they want you to find where the function is increasing and decreasing. I just want to remind you this. When you write the way they ask you to increasing or decreasing, we always have to use the interval notation. Okay, and we have to use the union notation to combine together. If you have more than one interval that make the function increasing, then you have to combine it by using the union sign. Okay, so let's investigate this graph. Where the interval of the function decreasing, look like the function decreasing from here to here, right? To here only. So we have to find the x value. The answer always the x value, okay? So from here, the x value is -5.4, okay? And over here, the x value is -1. Okay. So it's decreasing. It's decreasing. I'm sorry, decreasing on negative 5.4 to negative 1. Okay, I want you to notice this. Every time they ask you the make the function increasing or decreasing, you never use bracket. Never use bracket. Always parentheses. Even though if it is a circle here or if it is a dot here at the end of the graph, if it is even a dot, you use parentheses. Okay. Okay. So it's different from what we learn when we try to find the domain. Okay. For the domain, if it is a dot, we have to use bracket. Okay. If it is not a dot, if it's an open circle, we have to use parentheses. But for increasing or decreasing, it doesn't matter if it's a dot or it's an open circle. We always have to use parentheses. So the function here decreasing on this interval. Okay, how about increasing? So increasing from this, right, this point here to this point here, right? So you see this very increasing right here, and at this point here the x value is -1. So increasing on increasing on what? -1, right? Increasing on -1 to which stop right here, so about 2.2. Okay. Remember that increasing or decreasing or domain, the answer is the x value. We have to look at the x value. Only the range we care about the y value. Okay, and one more thing, which is the next question, we care about the y value. Okay, let's go to the part G. I think I missed one of the question over here, but I'm going to go for this one first. Okay, A, B, C, D. I think it should be, this is A, this is C, this is E, and the next one is G. Determine the value where fx is greater than 0. Remember, when we learn in function notation, we say what? We say y equal fx. So every time they say fx, which is the y value, and over here they want to determine the value. I mean determine x value that make the function make the y greater than 0. Oh, so over here you see that even in this question, the answer is the x value. The answer is the x value, not the y value. So we have to find the x value that make the function make the y value greater than 0. Literally, it means that we have to find the x value that make the function above the x-axis. Or because if it is slightly above the x-axis, then the y value is positive, right? So where's that? Look at that. You see the branch here. The branch here is above the x-axis, right? Okay. However, the branch right here, the curve here, is below the x-axis. And if we look at the branch, it's also above the x-axis. So we have two branches above the x-axis, which make the y value positive. The y value positive. Okay. So the answer will be what? the answer have space, so try to show you, but I don't have space. Oh, here you go. So the function over here, this branch over here, above this, or you can say the f(x) is greater than 0. So the value of the x value will be negative 5.3, negative 5.3 to negative 4, right? Union, we have to use union because as long as we have two more than one interval, then we have to use union from 2 to 3. See, from 2 to 3, because from here to here, the function is above the x-axis. Or you can say from here to here, all the y value, all the output is greater than 0. How do I know that I use bracket or parentheses? So you see that over here the question is not included. It means that we have to use parentheses. If it is included the equal sign here, then we have to use bracket. Okay. B. Estimate the y-intercept. Well, the y-intercept is easy. Y-intercept is right here. The y-intercept is the point where the graph intersect, where the y-axis intersect the graph. So right here, the y-intercept will be negative 0. It could be 0, negative 8. Okay. B. Find the x value that make the function f(x) equals 0. Which is f(x) equals 0. It means that is the x-intercept. X-intercept. Find all the value that makes the f(x) equals 0. So f(x) equals 0 when x equal 2. So x equal 2 and x equal negative 4. Because at this point, and this point here, the output is 0, right? Look at that. The output is 0. The output is 0. We kind of make a projection on the axis. Okay. Okay, like this. See that? Output 0 from here to here. Output. Okay. I made a projection on the y-axis. Yeah. For what x value the function is less than or equal 7? Oh, so this is less than or equal. It means that we have to use bracket over here. Less equal to 0, 7, 7, 7. So mean we have to look at the y because f(x) represents the y. So 7 right here, right? So f(x) less than 7, it means everything below here. Right? To here. So we have to find all the x value that make the function less than 7. Okay. So I make the projection on the x-axis. So 7 right here, 7 right here should be like this, right? I make a point. I pick a point here and make projection on the x-axis. There you go. See? The point here and make projection on the x-axis because they want you to find the x-axis. They want you to find the x. Okay. So make a point here and make the projection. Okay. Make a point here, make a projection. So your answer will be what? Will be around negative 5. Negative 5. We have to use bracket. Okay. So x-axis, right? The x point. And look at the x-axis. Negative 5 to 3. Okay. And we have to use bracket all the time because it's an equal sign. Okay. Okay, so that's all we have for section 1.3. Let's start it with section 1.4. On this section, as you know that we will learn a function, and there are many kinds of different kind of function. Um, and one of the very important and basic function we learn in college algebra is a linear function. So it's not different from what I already talked about in section 1.2 when I mentioned linear equation. Okay, so we also have standard form, the slope intercept form of linear function also. So it's not much different. Okay, but in order to investigate further, let's talk about the mathematical definition of linear function. Okay. So section 1.5. Linear function. Definition. So first of all, linear function is a function. Linear function must be a function, of course. Is a function whose graph is a straight line. And a linear function can be written in the form fx, because we always start with fx because fx is the notation of function. We already know that fx equal ax plus b, where a and b is a constant, which is a and b is just a number. A could be a fractional, and b could be fractional number also. A could be decimal number, and b also can be decimal number, or both. So a could be a whole number, b can be fraction. It doesn't matter as long as it's a and b is constant, and if it is written in this form, then that is a linear function. So you see, it's not much different from what we had in section 1.2, right? It's not much different. Example: fx equal to negative 3x plus 7. So this is a linear function. The graph of this function is a line. Okay, and the a value over here is negative 3. The b value is 7. Okay, or you could have something more interesting like 2 over 3x plus 8. 2 over 3 is fraction, and that is the a value, and the b value is 8. Okay, or maybe something even more fanciful, something like this: 1.5x plus minus 4 over 3, for example. A over here is 1.5. It's a decimal number, and b value is negative 4 over 3. It's a fractional number. It's a fraction. Okay, so all of this is a linear function. All this is a linear function because it has the form ax plus b. Okay, so let's go into detail how many kind of linear function, how many form of linear function we have. Okay, second Roman, formation of linear function. The first form we have is called slope intercept form, and this form has this form is fx equal mx plus b. Okay. And you see that it's not different from what we already had, what I already mentioned in section 1.2. It's the slope intercept form of linear equation y equal to mx plus b. Instead of the y, they put fi, and of course y equal fi. So it basically is the same. M is the slope, or is the modulus of the slope. We usually call it the slope. Okay, and the b is the y-intercept value. So in order to graph the linear function with this form, and the y-intercept value give us the y-intercept point. Okay, so it has the order pair form of 0, comma b. Okay, and the slope can be obtained by using the formula, the slope formula y equal to y2 minus y1 over x2 minus x1, given 2 points on the line. The first point has coordinate x1, y1, and the second point has coordinate x2, y2. So as long as they give you 2 points on the line, you can find the slope, and as long as you can find the slope, you can find as long as you can find the slope, then you can find the y-intercept easily. Okay, by using one of the points. You plug into the equation, then you get the y-intercept value. Okay, I will go through the example so that you can see later. Okay, or and another form of linear function is called slope point slope form. Called point slope form. Okay. Given a point, I call the point A with coordinate x1, y1. Okay, given a point, and as you already know that when you learn geometry in high school, as long as you get a point, then we can draw a line through that point, right? Okay, so that point must be on the line. Okay, so when I say given a point, it means that from I can draw the line through this point. That's what I mean. Okay, and the point slope form has the form as follow: y minus y1 equal m times x minus x1. Okay. M in this case will be the slope, and it can be obtained from the slope formula. Could be, or sometimes they give it you don't have to do anything. Okay, and the y1 and y2 is the point given. In this case, the point given is point A with coordinate x1 and y1. And I just want to remind you one more thing: any linear function, remark, any linear function has a constant rate of change. It means that it has a constant slope. The slope, as long as you get the slope is there. I mean, it's not changing. If you get the slope of 3 will be must be used for the whole process. Okay, for the whole math problem. It's not changing over the time. Okay, or it changed by any other reason. The slope is constant. It's there. It's fixed. Okay, it's a fixed number. Okay, so let's go through some example how to write a linear function using one of these form. Let me pick one of the example. Okay. Let me turn to another page. Example 1. I want to write an equation of a line. Okay, so as long as you heard the equation of the line, you know that's a linear function. Okay, most of the time they ask you the equation of the line. They never ask you the function of the line. But if they ask you the function of a line, you do the same thing. Okay, given the slope is -1/3, and the y-intercept value is -2. Oh, I think this one is the easiest problem I ever seen in my life, because they already given you everything already. Okay, you see that in this problem we cannot use the point slope. Actually, I can, but if you look at the problem, the question right away, you see that they don't give you the point at the beginning. They give you the slope at the beginning. They give you the y-intercept value at the beginning. They don't give you the point. Okay, as long as you don't give you the point, so don't try to use the point slope form. So I'll go ahead and use the slope intercept form. Y equal to mx plus b. So you see that it's not much different from what we already learned in section 1.2, right? We have to start with y equal to mx plus b, and we have to do two things. First of all, we have to find the slope. They already given you. Afterward, we have to find the y-intercept value, the b value, which is the one they already given you also. So I can write the equation right away. Is y equal to -1/3 x minus 2. And we're done. You got the equation, the linear function or linear equation. Okay, let's do the example that we have to use the point slope form. Okay, again, draw the equation of a line. Okay, given slope, let's make it up something. Okay, 2/3 going through point. I name it point A is 1, 2. Okay. Okay, and using the point slope formula. Okay, so we start with y equal y1 equal y minus y equal m times x minus x1. Okay, y1 x1 is the point A over here. Okay, so I can just go ahead and plug in. Y1 is 2, slope is 2/3 x minus 1, right? X1 is 1. So this is a point slope, and I can convert the point slope to slope intercept form easily. Okay, if the question asks you to do so, then it's not hard. So let's consider as an example number 3. I want to convert this point slope, form to slope intercept form. I will use example number 2 here. The answer we already get. So in order to get to this form, which is the form y equal to mx plus b, we already have y. Okay, all we have to do is we need to get rid of number 2, and we need to distribute the 2/3 into the parentheses. So I add both sides by 2, so I have 2/3 x minus 1 plus 2. I add both sides by 2 and cancel. Add both sides by 2 here and cancel that out, so I have 2 on this side. So it's almost there. But the slope-intercept form, we have only a number and an x. Over here we have a number x, and we have another number over here. So it's not good, right? It's not quite yet. So I have to distribute it. And I have to combine like term, combine the number here. So give you 4. So we're done. So you see that I convert the point-slope form into the slope-intercept form. In slope-intercept form over here, the m is 2/3 and the b is 4/3. And we're done, right? So you can convert the point-slope form to slope-intercept form easily by just add both sides by a number and using the distributive property. And we already learned also that if the slope is positive, okay, if the slope is positive, we have the line is increasing. Okay, remark. Just want to put a remark one more time. If the slope is positive, we have increasing line. So the lines go like this, right? So if the slope is negative, we have decreasing line. Slope will be, the line will be like this. But if the slope equals 0, we have slope equal to 0, we will have horizontal line. Will be like this. And the equation for horizontal line will be y equal a constant. For example, if you have y equal to 2, this is also a linear function, okay? It is also a line, but it's a horizontal line, okay? But how about if we cannot define the slope? If m is undefined, then we will have vertical line, okay? Vertical line looks like this, and it has the form x equal a constant. So x equal an example, x equal a number, x equal to, for example, -1. When I say constant, it could be anything. It could be negative number, it could be positive number, it could be fraction, it could be decimal number. Okay. So as long as you see the form x equals to a number, that is the line. It's just a vertical line. Okay. All right. So this reminder is very important. I want you to memorize it. Okay. So after we already know the line is when it's increasing, when it's decreasing, but sometimes on the graph we want to graph 2 lines, and sometimes those 2 lines overlap each other. Sometimes it kind of cutting each other. Sometimes it is perpendicular to each other. Sometimes it's parallel to each other. So we need to investigate in what condition 2 lines parallel to each other, in what condition 2 lines are perpendicular to each other. That's what we're going to do next. Okay. So I will name it as parallel, and perpendicular lines. Okay, so you see that the word lines are used plural because it must have 2 lines to be perpendicular to each other. Okay, if you graph only 1 line, what is the outer line? You know, we don't have the outer line to perpendicular to, right? Okay. So let's examine the first case, parallel. Okay, a parallel line look like this. Okay, I call it this line over here, line L1. Over here we have line L2. Okay. Okay. So the question is, what could we get out of it if two lines parallel to each other? And the answer is, as long as you have two lines parallel to each other, we have the same slope. It means the slope of line L1, I call the slope M1, is the same as the slope of line L2, I call it M2. So the slope is the same. As long as the slope is the same, the lines are parallel to each other. Okay. And it happened to be the same for the case two lines overlap each other. If it overlap each other, their slope is also the same. Okay. Second case, perpendicular line. Okay, perpendicular line is going to be look like this. Okay, we symbolize it 90 degree mean perpendicular to each other. This is L1, L2. Okay. So what could we get out of the perpendicularity between two lines? Okay. There's the product. It is the product of their slope will be equal to -1. Okay. Or you can say that the slope of one line will be the reciprocal, the negative reciprocal of the slope of the other line. Okay. And from these two properties, we can say two lines perpendicular to each other, or we can say two lines parallel to each other if we have this condition, okay, and this condition. So as long as you multiply the slope and the slope equal to -1, we can conclude that those two lines perpendicular to each other. So as long as you can find the slope of each line and you find that equal to each other, then you can conclude that those two lines parallel to each other. Okay. Okay. So it goes both ways. If you have parallel line, you can get this. If you can get this, you have parallel line. Okay. So I'm going to use the equivalent sign here to show you that it goes both ways. It can go both ways. If you have perpendicular line, you have this. If you have this, you have perpendicular line. Okay. So what happens if we have the line kind of intersect each other? It's not parallel nor perpendicular to or overlap. It is just intersecting each other. What happens? Well, if it intersecting each other, then we have different slope, and we don't have to worry about that anymore, right? Because as long as we have different slope, I mean, sometimes if it's a different slope, then it could be positive slope, negative slope. It could be increasing or decreasing, and of course, the line will be intersecting each other. Okay, so we don't have to investigate it because we already did that in the second Roman part. Okay, let's go to example. write the equation of the line. That pass through point 2, 3 and parallel to the line, another line parallel to another line y equal, and that another line has the equation y equal negative 3x minus 17. Okay, how we do this? Okay. Let's take a couple of seconds to think about that. Okay, so that's part A. Part B is perpendicular to another line, and that another line has the form, already have in the standard form. We have the standard form. I have 10x plus 5y equal 130. Okay. Solution. Okay, how we do this? Thing. Remember, every time we want to write an equation, what we have to write? What we need to find? We need to find the slope and y-intercept value, right? Because we want to write it in the slope-intercept form. That is our favorite formation of linear equation. Okay, that's my preference. Okay, you can use point slope, but I love slope-intercept form. Okay, so we start with this, right? It means we have to find M and we have to find B. Okay, so how we find M? Anyone can give me an idea how to find it? Okay, of course we use the information they give us, right? Over here they say parallel to, and I told you if we have parallel, same slope. So it means that the slope of this, and it's parallel to what? It's parallel to this. Okay? It means the slope of this is the slope of this. It means m equal to negative 3. Alright. We already go halfway. We need to find the b value and we're done, right? So in order to find the b value, we need to find it, we have to use the point. This information is the one we haven't used it yet. So we have to use this point. And remember this, in order to give you the point, just go ahead plug it in. So I go ahead plug it in, y equal 3, m is negative 3, x is 2, b, here you go, I can solve the equation easily. So I'll give you 3, negative 6 plus b, so b will be equal to 9. So you got a m, you got a b, you can get the equation, y equal negative 3x plus 9. Done, quick, right? Wait. Perpendicular, same thing. Perpendicular, the same thing. The equation we want to write will perpendicular to this line. Okay, it means that the slope will be, the new slope will be the reciprocal of the negative reciprocal of the slope of this line. Okay, are you thinking here? If we look at it, this is the standard form. If we look at this, we don't know the slope. We have to convert this to slope-intercept form in order to get the slope of this line. Okay. So how we convert it? Okay, convert this, and I need to remove this. So I have 5y minus 10x plus 135. So y equal to negative 2x plus 135 divided by 5 is 27, right? So look at that. I already converted really quick, right? This is linear equation. You must be able to do this. You didn't college algebra already, so I don't have to go through this again. So if you have trouble with this, please stay with me at the end of this class for a couple minutes, then I'll go through that with you, okay? But in the lecture, I cannot go through the basic solving linear equation anymore. Okay, so the slope of this line is -2. Okay, but the line we want to write has the negative reciprocal of the slope of this. So the m we want, the slope of the line we want to write will have the slope of -half, right? Because or positive, because the negative this, and make reciprocal to become 1/2, right? Okay. So we already know y equal 1/2 x plus b. We want to find b, and that line all goes through 2, 3. Plug it in 3, 1/2 2, b 3, 1 plus b. So b is 2. So you got b, you got m. So equation of y equal 1/2 x plus 2, and we're done. So it's not hard. It's not that hard. This is all you have to remember. In order to write the equation of a line, okay, you need to find two things. I repeat it many times already. You need to find two things. You need to find the slope, okay? Then you need to find the b value. You don't have the slope and the b value, we cannot write an equation. And in order to find the slope and the b value, we have to use the information they are given us. Okay, sometimes they come from the parallel line, sometimes they come from a perpendicular line, as this case, or sometimes they just give you right away. Okay, that case will be the easiest case. They give you right, they give you the m, they give you the b value, they give you everything. So that's the easy one. Okay. Okay, let's see. If I should go through another example, kind of the word problem, because we haven't done any word problem so far. I'm gonna pick one of the word problem in the textbook. Let's see. Okay, so well, I think you guys can handle this, because it's nothing really hard, because the writing equation is hard, but for the word problem they already give you equation and they just want you to interpret the meaning accordingly to the context, you know. So let me see. Let's do this one. Let's do this one. Number 6. Let's do number 6 here. Okay. Number 6 over here. It say what? Dwayne deposit money in his bank account and then use his savings to pay his rent of $500 each month. Okay, remember each month. Okay, you need the first month 500, but the second month you already paid 1,000. The amount of money in his account can be denoted by this function, where t represents the time in months and a is the amount of money in his account. A, interpret the vertical intercept using the complete sentence. Okay. What does it mean? Okay. Okay, so it means that at the beginning he has $4,000 and he start losing money for the rent every month, $500 every month. So the B value is right here. Okay, that's the B value right here. This is the B value. Okay, and remember the B value can give you the the vertical intercept, or you can say there's a y-intercept one. So it means for part A you can say that it means that initially he has $4,000 in the bank. Okay. For part B, interpret slope using complete sentence. Okay. And you see the slope is negative. Okay, so you see that the slope is negative. It means that he lose money because he pay for his rent, right, every month. It means that he lose $500 for each month for the rent. That's what it means. For each month, he lose $500. Okay, or you can say for each month he used 500. He spent $500 out of his bank account for the rent. You can say that. And for part C, how much money will be in the account after 5 months? Okay, after 5 months, and T represent the time in month. Okay, so after 5 months, and T represent the time in month. T is month. So after 5 months, I just go ahead and plug that in. So I just go ahead and plug it in. So A5 will be 4,000 minus 500 times 5 will be 4,000 over 2,500. You be U00 5 1,000. Yes, so it will be 1,500. Okay, so over after 5 months, it means after 5 months he lost $1,500 out of his bank account, which is out of his $4,000. Okay. For party, how many months rent can be paid until his account has zero balance? Okay. They ask you how many months, it means they ask you to find a T. Okay, and when his account becomes zero, it means the whole thing here becomes zero. Okay, the whole thing here becomes zero, so you can set up a whole thingy on the left side equals 0, 4,000 minus 500T. So you have 500T equal to 4,000. So T equal cancel, you have 8 months. So after 8 months, he used up his $4,000 for the rent. That's what it means. Okay. So out of this question, what you learn from it? The new thing you can learn from this question is that sometimes the function, they don't use fx. They can use anything. For example, in this case, they use a of t instead of f of x. They use a of t. Or if you look at the number 5, they use c of n. Okay. And over here, they use c of t. And t, in number 6 problem right here, t is a independent variable. And a is the dependent variable. Okay, so a sub t represents for the y. Okay, or a of t is basically is fx, but they don't want to use fx. They can use anything. I know that we learned that the function notation is fx, but it could be anything. I can name it g of x, k of x, h of x. Okay, It could be anything. Okay. As long as it's satisfy a vertical line test, that is the function. Okay. What else we learn from this problem? Um, Let me see. Well, I think that's all, right? Okay. I don't think anything else we can learn from this question over here. Okay. Oh, probably this. Okay. So if you see the slope is negative, it's the in some context, especially for them in this problem, it means it's is the depreciation value. The value is depreciated. Okay. If the positive, it means the value increasing. Okay. So in this case, you see that he lost money. Okay, he lose money over the months. Okay, if it, if it addition here, then he gain money, but it's the context will be wrong, right? Because he used money from his friend, so he cannot gain money by paying the owner, by paying his rent. He cannot gain money. He must lose money, right? Okay, so I think that's all for section 1.5, and this section is the last section of chapter 1. If you have any question relating to on the practice problem and an exercise in this textbook, just let me know and just go ahead and comment that on the YouTube video. Okay. On section 1.6, I don't think I'm going to cover section 1.6. So the section 1.6 is about lines of best fit right here. So I'm not going to cover this. Okay. If it's really necessary later, then I will come back and cover. But this is many other topics. It's more important than this, so I will not cover this for the time being, but later maybe. Okay. So yes, hopefully my lecture will help you understand the concept better. And if you if you like the video, please subscribe my channel to get more lecture in the future. And I'll see you next time. Next time I'll be talking about the first section of chapter 2. Okay, will be linear system. Okay, so okay, if you like the video, go ahead and subscribe it. Then I'll see you next time. Thank you so much.